Okay, so hi, hello my dear students, how are you all? I hope that everybody is fine, and I, Ritika, welcome back to welcome everyone to the Unacademy, which is the very amazing platform, right? So I will be telling you what is the Unacademy and what are we going to study today. But before that, a very important information for all the students of grade number 10. Now students, as you know that your final exams are approaching, yeah, your term 2 exams are going to start very soon. So what is the thing? The Unacademy is going to start certain crash course batches. Now these crash course batches are very important as talking about your examinations. Okay, we will be having various doubt sessions, we will be having various answer writing sessions, etc. So these crash courses will help you to score much more marks. Okay, it will help you to take your preparations to the next level. Now what are these crash courses and when are they beginning? I will be telling you soon. But before that, let us know a bit about me. So I am Ritika, a chemistry educator on Unacademy. I have completed my BTech in Electronics and Communication and have been awarded grade A by Cambridge English EOSL. Now, today we are going to basically focus on the modern periodic table. Okay, so students, as you know, the modern periodic table is a very important topic for your term 2 examinations, and we have already done certain parts. We have done certain sessions in which we learned a bit about the modern periodic table and how we got till the modern periodic table. That is, how much did we work, okay, how much trial and error method did we go into for having this modern periodic table. Alright, now students, you can follow the page Unacademy Champions. This is a channel on Telegram whose link is provided to you in the description box. Now why to join this channel? On this page, students, on this channel you will be getting daily information of all the special classes, of all the batches that go on here at Unacademy, of all the YouTube sessions, right? So you can be updated and you can join, and also you can share with your friends. So the link is provided to you in the description box. Kindly join the channel, and also if you like this video, kindly press on thumbs up, subscribe and press the bell icon so that you do not miss any update. Students, so we need a bit of help that is possible only by you. So kindly subscribe to the channel and share this video to your friends, okay, so that we can have at least 1,000 subscribers, right? Okay, now let's start with modern periodic table. So students, as you already know that we have done certain sessions on this particular topic, we will be having a quick revision on whatever we covered till now, and then we will be moving on to the trends that we see in the modern periodic table. Okay, so what is modern periodic table? It is a kind of table in which elements are arranged according to their increasing atomic number. So that is important here. The arrangement is according to the increasing atomic number. Those having equal number of valence electrons, that is the outermost electron, they occur at regular intervals or periods. Now, since the number of valence electrons of elements show periodicity, that is a kind of repetition, chemical properties show corresponding periodicity, which means a kind of repetition of the properties we are able to see in the elements. So this is our periodic table, the modern periodic table. Now, if I talk about the cause of periodicity, right? That is the repetition of properties. So why are we having this repetition? Because of the same number of electrons in the valence orbit, that is the outermost orbit. Okay, so if the atoms, they have the elements, they have the same number of electrons in their outermost orbit. It is the basic cause of periodicity. Okay. Now, properties that appear at regular intervals or in which there is a gradual variation, that is a kind of a gradual increase or decrease, okay, at a particular interval, it is, or they are defined as periodic properties, and this phenomena, it is defined as periodicity of elements. Now talking about the modern periodic table. So our modern periodic table, it is having groups and periods, right? So the vertical columns in the periodic table that we have moving from up to down, they are known as groups, and from left to right we are having period. Now let's talk a bit about period and groups. So groups, the modern periodic table, it has got 18 vertical columns comprising of groups. Okay. Now let's have a quick revision about the groups, and then we will be moving on to the period of periodic table. Okay. So we have 18 groups in the periodic table. Right. Okay. If I talk about the elements of group 1A, 2A, 3A, 4, 5, 6 up to 7A. That is from group number 1, 2, then we have 13, 14, 15, 16, 17. 13, 14. They are known as what? Main group elements or representative elements or normal elements. Okay. Next, the elements of group number 3 to 12. They are known as transition elements. Alright. Okay. And next we have the group number 18, which is the zero group. So it consists of noble gases or inert gases. And why are they known as noble gases? Because their outermost shell is complete. Okay. Next is the periods. So in our periodic table, we are having 7 horizontal rows, okay, from left to right, and each is known as period. Now, how to determine a period? It is determined by number of shells which are present in the atom. Okay. Now, elements with electrons increasing arithmetically in outermost shell, that is 1 by 1 till an octet is attained, are placed in same period, and the last period or last element of each period, it has got 8 electrons. Now see students here, first of all, number of shells equals to number of or period number. Okay. For example, if I take the case of hydrogen, lithium, okay. Now first hydrogen, the atomic number is 1. That is, it will be having only 1 electron, right? Now what will be the diagram of hydrogen over here? This will be the nucleus and this is the first shell having 1 electron, right? So we have 1 shell. So that means hydrogen is from first period. Similarly, if we go for lithium having atomic number 3, so the configuration will be 2, 1. So this will be the nucleus of lithium. This will be the first shell and this will be the second. So we are having 2 shells. That means lithium belongs to second period. Then we have sodium. So sodium, the atomic number is 11, that is 2, 8, 1. So how it will be placed? This is the nucleus. The 2 electrons will be placed here. The 8 electrons will be placed here. And 1 electron, it will be placed here. So we are having 1, 2 and 3 shells. So 3 shells, it means it belongs to the third period. Okay. So that is how the number of shell, it is equal to the period number. Okay, next thing that we learned right now is in a particular period, Okay, we have elements who have one atom in their valence shell and it subsequently increases till an octet is attained. And the exception in this particular rule is the helium, which has got only 2 electrons. Okay, now if I talk about the group, so we have lithium, the group 2, right? I'm sorry, the period 2. So we have lithium. So lithium is having how many electrons in the outermost orbit? We have 1, right? Now, when we will be moving forward in the group, what will happen? This valence electron, it will increase continuously. Okay. So, for example, if we are moving from lithium to beryllium, okay, then we are moving to boron, carbon, nitrogen, oxygen, fluorine, and neon. So, at neon, we will be having the 8 electrons in the orbit. So, the atomic number of neon is 10. So, it will be this configuration. Alright. So, this is how elements are arranged. So, lithium, it will have 1, then 2, then 3, 4, 5, 6, 7 and 8 electrons. Okay. So, the only exception over here, it will be helium, as I already told you. So, it will just have 2 electrons in the outermost orbit. Okay. So, that is how the arrangement is done. Okay. So, I hope that is very much clear to you. Okay. Now, let's talk about the period over here. Now, we have first period. It is containing how many elements? 2 elements. That is hydrogen and helium. So, that is why it is known as the shortest period. Then we have the second and third period, and they have 8 elements, referred to as short period. After this, we have fourth and fifth period, which have 18 elements, and they are referred to as long periods. After that, we have 6th and 7th period, who have 32 elements. Therefore, it is referred to as the longest period. Clear? Now, students, in the group 3rd B of 6th and 7th period. Okay, so the group 3rd B of 6th and 7th period, we are having special elements. So, in the 6th period, we have lanthanoids, which are also known as rare earths. And in the group 7, we have actinides, which are known as radioactive elements. Okay. Now, these are not actually placed in the periodic table, but these are placed below the periodic table, because if we try to add it into periodic table, it will disturb the whole, the shape, or we can say whole, arrangement of the periodic table. Okay. Now, next is types of elements. So, we have 4 types of element. First is representative. Then we have transition. Then we have inner transition. And at the last, we have inert gases. So, we have already completed these 4 types of elements, right? We will quickly have a revision on this. So representative elements, these are the elements who have their outermost orbit incomplete. Okay, so they are also known as S and P block elements that you will be studying in your future classes. So here we have group 1, group 2, group 13, 14, then we have group 15, group 16 and group 17. Okay, so these are the elements which come under the category of representative elements. Now, talking about the representative elements, we have both metals and non-metals here. Next is they form electrovalent and covalent. Both type of bonds we can see. Okay, then talking about metallic nature. So metallic nature, it increases down the group. Okay, so these are some of the properties. Then we have transition elements. So these include the elements from group number 3 to 12. So these have high melting point and boiling point. They are generally good conductors. Then most of the elements of this particular group, they are magnetic. They show magnetic behavior. Okay, and they also show variable valencies. Okay, then we had inner transition elements. So the 6th and 7th period of group 3, that is, right now we saw the lanthanides and the actinides. They are the inner transition elements. And last is the element of 0 group. Okay, that is the 18th column. It is known as inert and noble gas. So why are they known as inert or noble gases? Because they have their octet complete. Okay, and in case of helium, it is 2 electrons. Okay, now octet complete, so they have a stable electronic configuration. And since they have a stable electronic configuration, they do not react with other elements. Okay, next is the merit of periodic table. So first, it is based on atomic number. So that is a good, or we can say better, fundamental property. So it is based on atomic number. Next is, we can see regular trends. And it is easier to understand. Okay, or we can also say the position of element. It is related to the electronic configuration. So we have not just taken any element and put it like wherever we want. It is related to the electronic configuration. So these are some of the merits of the periodic table. Now if I talk about the defects, so first is the position of hydrogen. So hydrogen, it shows the properties of both the group 1, that is the alkali metals, and group 17, that is the halogens. So it is still a confusion like wherein to put the hydrogen, or what is the basic or appropriate place for hydrogen. Okay, so that is the thing, that we do not exactly know the position of hydrogen. Next is no accommodation for transition, inner transition elements, that is lanthanides and actinides. So these are the two basic defects of periodic table. Okay, now students, a very important information for all the students. This new year, Unacademy has brought with it an amazing opportunity for all the students. Okay, so you can not only learn, but you can win while you learn. Okay, so Unacademy Prodigy, it is back with exciting prizes and rewards. You can enroll yourself now for free of cost. This test is scheduled to happen on January 23rd, so very soon, right? From 12 p.m. to 1 p.m. You can click the link which is given below for more details in the description box, or you can join the Telegram channel to receive or to have a detailed information of Unacademy Prodigy. So students, please share this news maximum. Okay, share it with all your friends so that all can take this test and all of you can win exciting prizes. So this offer is valid for all the live test takers, and please hurry up, share it and prepare so that you can win the amazing prizes. Okay, now we will be moving on to the trends of modern periodic table. Okay, so we will first begin with the group and then we will see for the period. So in the groups, the number of shell and valence electrons. So in the group, what happens as we are moving from top to bottom? What happens? First of all, the number of shell, it increases, right? Okay, and talking about number of valence electron, it remains same, or valence electron is equal to the number of group. Okay, now if I talk about, let's say, the group number 70. Okay, so we have fluorine, chlorine, bromine, iodine. Let's take the case of these 4 elements. Now, talking about the shell, we have 2 shell in fluorine, 3 in chlorine, 4 in bromine, 5 in iodine. Okay, that is their configuration is 2, 7, then 2, 8, 7, 2, 8, 18, 7, then 2, 8, 18, 18 and 7. So this is how the electrons are accommodated. Okay, so the number of shells, it is equal to the period to which the particular element belongs. And as we are moving from top to bottom, the first or the main thing, if I talk about the number of shells, it will increase. Okay, now next is the valency. So what is the valency? Valency of any element, it is equal to number of electrons in the valence shell. Right. So for any particular group, the elements will be having equal number of valence electrons. Okay. So if I talk about in a group, the valency of elements, it will remain same. Right. For example, if I take the case of, let's say, the group number 1, that is okay, so these are the elements. Okay, now the valency of all these, that is the outermost electron, it is 1, right? So the valency of all these elements, it is 1. So as we saw that as we are moving from top to bottom, the valency, that is valency of any group, it remains same. Okay, now talking about the valencies. So if I talk about valency of group 1A, it is 1. Okay. Next, valency of group 2A, it is 2. For group 3rd A, that is group number 13, the valency will be 3. Group 14, the valency will be 4. Group 15, okay, from here we will be seeing a change. Okay, so for group 15, the valency will be again 3. Group 16, the valency will be 2, and at the last group 17, the valency will be 1, and at the last the group 18, it has 0 valency. Now how are these elements getting the valency of 3, 2 and 1? So for group 15, what do? Is we do 18 minus 15. Here we go for 18 minus 16, 18 minus 17. So the elements of group number 15, 16 and 17, they have got the valency 3, 2 and 1 respectively. Okay, and group 18, as you all know, they are the inert gases, they do not react, so the valency is 0. Next is the properties of elements. So if I talk about a group, they will have what? They have similar electronic configuration, right? Now if I talk about the properties over here, what will happen? Because in a group, all the elements, they have got similar electronic configuration, that is same number of outermost shell, okay, same number of electron in their outermost shell, so they will have similar physical and chemical properties. Now of course there is a change, a little bit of change, okay, so we can see a uniform change maybe down a group, okay, so the properties will change but they will be kind of similar. Okay, now if I talk about the group 1, so these are what? These are the alkali metals, right? Okay, now if I talk about down a group, that is lithium, sodium, potassium, rubidium and cesium. Now alkali metals, they are first of all reactive, okay, so they are highly reactive. Now if I talk about the degree of reactivity, as we are moving from top to bottom, the reactivity increases. Okay, so what is the thing that we saw? All of the elements are of course reactive, but this degree is further increasing as we are moving down the group. Now talking about halogens, okay, so that is group number 17. We have fluorine, chlorine, bromine and iodine. So halogens are also reactive, okay, but as we are moving from top to bottom, from fluorine to iodine, the reactivity is decreasing. So if I need to say what is the most reactive element, it will be fluorine, then chlorine, bromine and iodine. So what is happening? We are seeing a kind of general trend that something is maybe increasing or something is decreasing, but it is a gradual change, gradual increase or gradual decrease, right? Okay, next is atomic size. Okay, so of course as we are moving down a group, what is happening? Number of shells are increasing. Okay, and as the number of shells increase, the atomic size will of course increase. Now first of all, let's talk about what is meant by atomic size and how do we measure it. So for example, students, I am having one element, okay, and this is the structure. So what will be the atomic size? It will be the distance from the center of the nucleus to the outermost shell. Okay, so this will be the distance. Now this distance, it is very small, so either we measure it in angstrom or picometer. So angstrom is 10 raised to power minus 10 meter and picometer is 10 raised to power minus 12 meter. So students, as we are moving from top to bottom, what is happening? Number of shells is increasing, right? So for example, in the first period we have 1 shell, second we have 2 shell, 3, 4, 5, 6 and 7. So as we are moving from top to bottom, what is happening? Atomic size is increasing. Let's take example again of group number 1, that is lithium, sodium, potassium, rubidium and cesium. So here we have lithium 2 shells, 3, 4, 5 and 6, right? So as the number of shells are increasing, what is happening? Number of shells increases and therefore what happens? The atomic size is increasing. Okay, so that is how the atomic size increases on moving from top to bottom in a group. Next is metallic character. So what is metallic character? If I talk about the metallic character and how is it affected from moving from top to bottom. Now it is how easily any element, it can give the electrons to have the positive charge. Okay, for example, I am having any metal, okay, it will give one electron to have a positive charge. Okay, now as we are moving from top to bottom, the metallic character or the metallic nature, it increases. Okay, now if I go for group number 15, okay, so we have nitrogen, phosphorus, arsenic, bismuth. So these are the elements. Now as we are moving from top to bottom, we say that the metallic character or this nature, it is increasing bit by bit. So this will be, as it is lying down in the group, so it will be most metallic and here it will be least metallic, that is non-metal. So here we have these two are non-metals, these are metalloids, and here bismuth, it is the metal. Talking about another group also, let's go for some other group. Okay, so if I go for first group, okay, so as we are moving from top to bottom, the metallic nature, it will increase subsequently. Okay. Okay, now next is, okay, again a very important information for all the students of grade 9 to 12. So as I told you, Unacademy is continuously rolling some of the new plans and some of the new offers for all the students. There is another amazing offer for all the students. Now the ICSE board students for grade 9 to 12, there is an amazing offer for you on Plus subscription. And what is that offer? We are going to have an offer of 3-month extra subscription. Now what is that? If you buy a Plus subscription for grade 12 and above, first is you will be getting a 10% discount. That is right. But apart from that, you also will be getting extra 3-month subscription for K-12 absolutely free of cost. Now students, This particular offer, it is valid for first 500 subscribers only. So it's a kind request that please hurry up so that you can avail this offer as soon as possible. Next is, okay, so next we were moving on to the period. Okay, so we will be seeing some of the general trends that we see across left to right in a period. Now, first of all, number of shells and valence electrons. Okay, now if I talk about any period as we are moving from left to right, what is happening? The number of shells is same. Right, so the number of shells, they remain same as we are moving from left to right. If I take case of third period, so what are the elements that we have? We have sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon. So the atomic number over here, it is 11, 12, 13, 14, 15, 16, 17 and 18. Now talking about their electronic configuration, we will be having the configuration as 281, 282, 283, and this way we will be reaching up to 2,8,8. Now in the case of electronic configuration, these are the division of the shells, right? So we have 1, 2 and 3 shells, right? So 3 shells in case of sodium, and here also we have 3 shells in case of argon. So what do we notice? The number of shells, they are not increasing. They are same. Okay. Talking about the number of electrons in the valence shell, they from left towards right, what is happening? There is increase in valence electrons, right? So the valence electron, they increase one by one. Okay, so from sodium, it will be increasing 1, 1, 1. From magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, there will be 1, 1 increment. And talking about number of shells, from left to right, it remains same. Correct? Okay. Next is the valency. Now, what happens in the case of valency? Now, if I go for with respect to hydrogen, okay? With respect to hydrogen, what will happen in valency? It will increase from 1 to 4 and from 4 to 1. So in the case of, let's say, the second period, that is lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine. Okay, so what will happen here? Lithium, it has got valency 1, 2, 3, 4, and here it will be 3, 2 and 3, 2 and 1. So this will be the kind of gradation or a change. Now if I talk about with respect to oxygen, now with respect to oxygen, what happens? The valency, it increases from 1 to 7. Okay, for example, if I take the case of the group number 3rd, that is sodium, magnesium, aluminium, silicon, phosphorus, sulfur and chlorine. So the valency will be 1, 2, 3, 4, 5, 6 and 7. So how the oxides will be formed? Here if I talk about the oxides, it will be Na2O, MgO, both 2. Then aluminium, it will be Al2O3, SiO2, P2O5, then we have SO3, and chlorine, it will be Cl2O7. So the valency, they are continuously increasing, as in case of oxygen 1 to 7. With respect to hydrogen, it is increasing up to 4, decreasing up to 1. So 1 to 3, 4, 3 to 1, it is the general gradation. Now if I talk about the oxides over here, it will be lithium hydride, LiH, then BeH2, then BH3, CH4, then in the case of nitrogen we have NH3, H2O and HF. Okay, so this is the change that you will see. Okay, next is the properties of elements. Now talking about the properties of elements, these depend on the number of valence electrons. Okay, so the number of electrons which are that are present in the outermost orbit, the properties are more or less defined by that. Okay, so what happens as we are moving from left to right across a period, what is happening? The number of outermost electrons increases, right? So they are increasing from 1 up to 8. Now talking about the reactivity. So if we go from left to right, what happens is reactivity first decreases, okay, till group number 14, and then it increases. So according to this, what will happen? Group 1 elements, they will be very reactive. Okay, and they are metals. Okay, as the metallic character, it is also decreasing as we are moving from left to right. And group 17 elements, they will be very reactive non-metals. Okay, all right. Now let's talk about atomic size. Okay. Now there are two things which we need to remember or we need to note in the case of atomic size. Okay. So first is the number of shells. And second is nuclear pull. Okay. Now talking about number of shells, what is happening? It remains the same. So according to this trend, we should be thinking, or people might be thinking, that atomic size is same. But no, it is not the case. What happens is, as we are moving from left to right in a period, the number of shell is same, right? But nuclear pull is increasing. Okay. Now, because of this nuclear pull, okay, what happens? See, this is the nucleus, okay, and these are, let's say, the shells. So, because of the nuclear pull, what the element or the atom tries to do, it tries to pull the electron towards the nucleus, right? So, for example, this is the whole atom. In the nucleus, the more the nuclear pull is there, the more it will try to pull the electron towards itself. Okay. Now, for example, we are having electrons over here. So, if the nuclear pull over here increases, what will happen? It will try to pull the electron towards itself. Okay. And if it tries to pull the electron towards itself, the size of the atom, it will be kind of shrinking, right? So that is why what happens over here is, okay, as we are moving from left to right, atomic number is continuously increasing. Okay, so for example, if I move from lithium to beryllium to boron to carbon to nitrogen to oxygen to fluorine. So what will happen? The atomic number is continuously increasing. And as atomic number is increasing, what is happening? Nuclear pull is also increasing. Okay. Now as nuclear pull is increasing, what will happen? It will try to take the or bring the electron towards the nucleus. It will pull it. Okay. So the size of atom, it decreases because of this nuclear pull. So according to this, what will happen? As we are moving from left to right, the nuclear pull is increasing. So according to that, the greatest size will be of lithium over here. Then we have beryllium, Be. Then we have boron, carbon, nitrogen, oxygen and fluorine. Okay, so that is the trend. Okay, so atomic size, if I talk about down a group, what happens? It increases. Okay, and if we go for across a period, the atomic size, it decreases. And what is the basic or the main reason behind the decrease in the atomic size? It is the nuclear pull. Okay, so I hope that is very much understood. Next is the metallic character. So as we are moving from left to right in the periodic table, what is happening? The metallic character, it decreases. Now what is the explanation? So if I talk about the very first element of group number 2, that is lithium. What is the configuration? It is 2, 1. Okay, so it has got 2 electrons in the first shell and 1 electron in the second shell. Now how many electrons does it need to achieve a stable configuration? It needs 8. So there are 2 chances with lithium. It can either donate its 1 electron or it can gain 7 electrons. Now what is easy? Donating 1, right? So the metallic character is more or less dependent on the same thing, that how easily any element it can donate the electrons to achieve a stable configuration. So this is what happens. So what happens? The lithium, it takes the 1 electron. It donates the 1 electron. Now as we are moving from left to right, what happens? The atomic number is increasing. Okay, now let's take the case of other one, that is fluorine. Okay, so the configuration of fluorine is 2, 7. That is, fluorine is having how many atoms in the, or how many electrons in the outermost shell? It is 7. So how many does it need to complete or to achieve a stable configuration? It needs 1 electron. So there are again 2 cases here. Either fluorine can take 1 or it can donate 7. Okay, so again, which is more easy? Taking 1. So this will be the character which is electronegative. It will be taking the electron. So as we are moving from left to right, the metallic nature, it will be decreasing. Okay, so what will be happening over here? Let's see. Yeah, so on moving from left to right, metallic nature or metallic character, it decreases. So if I go for the second period, we have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. So neon is again a stable configuration. Okay, it's inert gas, so there's no question over here. Talking about lithium and beryllium, they are the metals. Boron is a kind of metalloid. and these will be non-metals. So what do we know? That metallic character, it decreases as we move from left to right in a period. Okay, so I hope that is very much clear to you. Now let's do some of the questions. In which group halogens are placed in the modern periodic table? So the group number 18, it has got inert gases. Group number 17, of course, it has got halogens. Group number 2, we have alkaline earth metals. And in group number 1, we have alkali metals. So the correct answer will be group number 17. Of course, I'm sorry, it's A, B, C, and D. Okay. In the modern periodic table, the elements are arranged in increasing order of what? So first is atomic number, atomic mass, randomly arranged, or none of these. So the correct answer will be atomic number. The number of shells is equal to what? So is it groups? No. Periods? Yes. Both no and none? Of course no. Alright. Now let's have some important information, and then we will be quickly revising about what we learned in our today's class. So students, as you might be knowing that Unacademy is having the online classes, so there are many benefits of taking the Plus subscription. So some of the reasons as why you should be taking the subscription is, first and foremost is your exams are going to approach soon, very soon, right? So it becomes a very crucial time for all of you to start your preparations very seriously. Okay. Now, if you subscribe to Unacademy Plus, there are certain special things that you are going to get. First is you can learn from the comfort of your home. Then you will be having unlimited access to all the courses that you purchase. You will be taught by top educators of India on very one platform. And also we will be having regular sessions, that is doubt clearing and answer writing sessions. Okay. After that, in the doubt clearing session, okay, so basically we are going to discuss all the doubts that generally students have. And in answer writing session, you will be taught as how to manage your timing, okay, manage those 3 hours, and how to write the answers effectively so as to increase your scores. Next is exhaustive coverage of syllabus. Your syllabus will be covered. You will be under the mentorship and guidance of your mentors, of your educators. Then you will get all the study material in the PDF format so that you can refer to it whenever you need. Not just only the studies, we also have practice tests. So we will be having regular practice tests. Okay. So, you can access yourself, you can know how much you need to work hard and how much you are very good, how much you are doing good. Next is we have live test series and also the batch courses. So as I already told you, the batch courses are soon going to begin. We have 2 courses, which is Mavericks and Udan. So students, the Mavericks, which is the English batch, it is going to start from 17th of January, as I already told you. Please enroll yourself faster. We will be covering all the important things of your syllabus. Okay, and also Udan, which is the Hindi language batch, it is also going to start from today. So it's high time, students, that you start to subscribe for Plus and you take all the advantage of the classes that go in here. And students, you can use my code, that is RITIKACLIVE, to have daily practice session. You will have weekly mock test, live quizzes, daily MCQ and subjective test series. Now Unacademy Plus subscription for ICSE board. So you can subscribe for whatever plan you are comfortable with. that is 6 months, 12 months, 24, 36, whatever time duration you want to go with, please select that and then use my educator code, which is RITIKACLIVE. So please use that to get 10% discount. So here is the batch that I was telling you about, Mavericks, which is an all subject batch with delivery language in English. Okay. Now students, if you subscribe for grade 9, you will be getting the subscription of grade 10, 11 and 12 absolutely free. So that is a very amazing opportunity. Please go avail it. And similarly, Udan, it is the all subject batch in Hindi. Again, same thing. It is going to start from 17th of January. And if you subscribe for grade 9, the subscription for grade 10, 11 and 12, you are going to get absolutely free of cost. Now talking about the Unacademy free special class. So what's so special about those special classes? First of all, they are free of cost, so anybody can watch it. We will be having live real-time interaction. We will be having various chats, emojis, poll leaderboards wherein you can compete with your friends and you can see the leaderboards. And also students, you can ask questions using question tab. Next is how to watch my special class. So the thing that you need to do is you have to download the Unacademy Learner app. Okay, and when you open the app and click on get started, enter your mobile number and you will be receiving the OTP. Okay, just sign up using your email ID. Just put in all the information that you need. Okay, and in your case, the goal that you're preparing for, it will be for grade 6 to 12. Select your grade, select your class and board, that is CBSE or ICSE, and select the class that you are in. Next is you will be asked what language do you prefer to learn in. You can select English, Hindi, English, whatever you want to. And now in the description of this video, there is a link of the special class. Okay, you can click on that link and you just click on notify me. So you will be notified just 10 minutes before the class is going to begin. Okay, and you can use my code, that is RITIKACLIVE. So this code, it will be used to unlock the special class for free of cost. Okay, alright, so I hope you might have understood everything. Also, please join Telegram channel to receive a more clarity on all these things. Okay, now talking about our learnings for today. What are the things that we have learned? We had basic recap of modern periodic table and we learned about the general trends. Okay, so we learned about period, we learned about the groups, how many groups do we have, how many period, and then we learned about the general trends or the general changes that we see in the periodic table. That is, what is the number of shells, what's happening to number of shells, what's happening to atomic size, what happens to the valency, what happens to the size of atom, what is the change that we see in the properties. Okay, so I hope that you might have understood everything that we have covered today. Please download the Unacademy Learner app. You can get it on Google Play Store or App Store, and please try all these features for free. I'm sure you're going to love it. So you can use my code, that is RITIKACLIVE, to unlock all these features for free. We will be meeting in the next class in which we will be learning a lot more important things. Okay, so till then, keep studying, keep learning, watch the special classes, take care, and all the very best for your preparations for your term 2 exams. Thank you everyone. Let's meet in our next session.